Hello, intermediate algebra students. Today I am not in the building, so we're just going to deal with 10.1. We'll save 10.2 for Friday, maybe a little bit Monday. We'll see how that goes. But I do have an old set of notes attached to the checklist. And then this is just a little bit deeper dive on some actual examples from the Alex homework. So definitely check out the other set of notes. There's going to be some good vocabulary work in there, and there's some good visuals. Even if you look through it for just a few minutes or have it pulled up while you're doing your homework, it is going to be useful. But this is going to be a chance for us to walk through some of these examples together. First of all, dealing with some of those vocabulary terms, we're looking for leading coefficient and the degree of the polynomial. Well, first of all, this all requires us to first be in standard form. Now, when we talk about quadratics in not too far away times, we'll see standard form of that would be ax squared plus bx plus c. And one thing that you can take note of here that applies to what we're talking about today is the biggest exponent on a variable comes first, and then the smaller exponents go down in order from there, from left to right. And then the last one is going to be that constant, that value that is just a number with no variable attached. So in order for us to get this into standard form, we need to rewrite it with the biggest variable first, which is going to be the 9w to the 8th. Okay, so we're going to have a positive 9w to the 8th first. The next biggest variable exponent is just the single negative w. It's a minus w happening. You want to keep that positive or negative with it. And then the minus 6 is last. That constant is always going to be last. That value that is just a number. So you've got the 9w to the 8th minus w minus 6. And all that matters for these two questions, the leading coefficient is what that term means, is the number that is in front of a variable when they're attached. So the leading coefficient is the leading value attached to the biggest exponent variable. A lot of big words there, but when you write it in standard form, it's that first number, so it's a positive 9. And the degree of this polynomial is whatever the exponent on that leading term is. So once you have it in standard form, you're just picking out those two values. Now, when we actually get to simplifying some of these things, well, first of all, you're going to be adding and subtracting polynomials quite a bit today. Now, polynomials are these expressions that are more than one term long. So negative 4x squared plus 5x is one whole polynomial, and negative 3x squared minus 7x plus 1, those are two full polynomials, the one in underlined in red and the one in green. Now, when we're combining them, when we are adding, you are just adding and combining all the like terms with the sign that is out front of them. So we're basically saying we're taking this big chunk plus this second big chunk. Now, when you're just simply adding everything together, there's no multiplying going on, there's nothing to distribute, which is what we're going to see in 10.2 and beyond. You're just adding everything together. You're basically ignoring those parentheses. So essentially what's happening is you've got a negative 4x squared plus 5x, and then you're adding a negative 3x squared, which is just minus 3x squared. All those terms in that second polynomial are just going to be using the symbol that's attached to them. Minus 7x plus 1. And all you're doing here, I like to use different shapes and colors when we're going through the notes like this. All you're doing here is just combining all the like terms based on their exponent term, or their variable term, right? And then the one thing to remember is that when there's x squareds and x's, although they are the same variable, they're the same letter, they're different terms because one of them is squared, the other is not. So x squared is not the same as just a single x. With y squared and y, x squared is as different from x as a w is from x. Okay, they're not the same even though it's the same letter. So when we're going to start combining our like terms, we can put boxes around the x squared terms. Okay, and then let's put circles around the x's. and then we'll just underline the constants, and it's just that single plus 1 at the end. So when you combine them, you're just combining them with the signs that they have. So a negative 4x minus 3x. Really all that's happening there is negative 4 minus 3, and the x squared is just saying what type of term it is. So negative 4 minus 3 more is going to be negative 7, and it's an x squared term. With the x's, we've got 5x minus 7x. Again, really, it's just 5 minus 7, which is negative 2, and it's an x term because they're both an x. And then that plus 1, there is no other constant to combine with it, so it just stays as plus 1. You have no more like terms in that situation. There's nothing else that can combine. You are fully simplified, and you are in standard form because the biggest variable comes first, biggest exponent comes first, and it goes smaller as we go to the left, to the right. Excuse me. And that's it. You would be done there. Now, the one slight change when you're subtracting is you're essentially distributing a negative 1 to that second coefficient. You're subtracting everything in there. So we're subtracting a 6x squared, we're subtracting a negative 3x, and we're subtracting a negative 2. That negative 1 is almost distributing through there. So then when you rewrite this without the parentheses to get everything out in the open, we have 7x minus 2. Nothing's happening to those two terms in the front polynomial. And then minus 6x squared. It's just minus 6x squared. It's like a negative 6x squared. Minus a negative 3x is minus a negative is plus. So really it's just flipping that sign. So now we're saying plus 3x, then minus a negative 2 is going to say plus 2. So there's one thing to be paying attention to when you're subtracting a polynomial. You're basically distributing that negative 1 through, and the back polynomial, just you can see all their signs flip because of that negative. Once you're here, it's exactly the same as the first problem. We've got a negative 6x squared, and nothing else is going to go in a green box. We've got a 7x and a 3x. Nothing else is going to go in a blue circle. And then we've got a negative 2 and a positive 2. So when we start to combine these, that negative 6x squared, to put this in standard form, that squared term is going to go first. That's the only x squared term, so it just stays that way. There's nothing to combine it with. 7x and 3x. 7 plus 3 is going to be 10, so we're going to have plus 10x. It doesn't turn into x squared. That's when you're multiplying variables. Nothing like that's happening. You're just combining the like ones. It's still just an x term. So then we have plus 10x. And then when you see this negative 2 plus 2, that equals 0. So essentially, they're gone. You're not going to put a plus 0 on here. You don't have to do that. Okay? So since those constants drop out, they cancel each other. That's all you have left. And that would be your final answer. Now you're going to see some of these things with 3 polynomials. Now I'm just going to go through that first step on this one, just to save a little time. You're just treating these one thing at a time. So you see this situation where we're subtracting this polynomial. So that's where we have to treat this grouping like we're distributing a negative 1. So this first one, the negative 2y squared plus 7y minus 6, nothing is happening to that. Nothing is changing it. There's nothing out front multiplying it. So negative 2y plus 7y minus 6. Now then in the middle, when you have a negative y squared, we're subtracting negative y squared. Remember, it essentially just flips that sign. So you have a plus y squared minus a negative 4y will be plus 4y, and then minus a 3 will be minus 3, and then nothing is happening in this grouping because they're all positive, or excuse me, they're adding that group, so everything's just adding on with the sign that they have. And you're going to end up with a plus 2y squared plus 4y minus 9. And you would go ahead, that looks like a whole bunch of stuff coming ahead of you, but you're just combining them the same exact way we combined the last couple. Okay, so you would move forward from there. The next one I do want to touch on here. It is an addition problem, so we don't have to worry about addressing the negative. There's nothing to be distributing for a negative 1. So remember, when you have a addition of polynomials, you're essentially ignoring these parentheses. It's like they're not even there because everything is just going to combine with the symbol that they have. So we're just going to kind of cover those up and go from here. Now, like we talked about with x squared not being x, same thing here. We have an x squared y cubed term, 5x squared y cubed. That is only going to combine with other terms that have the exact same variables and exponents. So only the other terms with an x squared and a y cubed are going to group with that. That's going to be this one, negative x squared y cubed. Nothing else is exactly the same as that. Then we have a positive 4x cubed y squared. That's only going to group with the other x cubed y squared terms. And then lastly, the y to the third power, the y cubed, those two are going to combine. So when you actually combine these, okay, you've got 5x squared y cubed and negative x squared y cubed. When it's just subtraction like that, there's no number. There's technically a 1 out front. And really, all that you're doing is 5 minus 1. That's really the only math you're doing here. Number-wise, the only arithmetic you're doing is 5 minus 1, which is 4. And then it's going to keep that variable expression behind it. 4x squared y cubed. And then in green, 4 minus 6 is really the only arithmetic you're doing. 4 minus 6 is negative 2. And what type of term was it? It was an x cubed y squared. And then when you've got negative 7y cubed plus 3y cubed, again, you're just doing negative 7 plus 3, which is negative 4. So you have negative 4y cubed. And that would be your final answer. And then the last one that I wanted to look at here is just to touch on some of the vocabulary here, and I want you guys to kind of address this question on your own because I think it's going to be these same 6 questions for everybody. There's just one of these on there. An integer is just a positive or negative whole number or 0. So they're just saying a whole number and a whole number. So all those integers that they're mentioning. So a whole number plus a whole number equals a whole number. You would say always, sometimes, or never. Okay. And then a polynomial is what we talked about, just these expressions with multiple terms. So that would be something like x plus 2. Okay. So a polynomial plus another polynomial gives us a third polynomial. So always, sometimes, or never true. So try your best with those. Just a little bit of vocab work and practicing what happens with adding, subtracting. These ones, the multiplying ones, see what you can get with that. Okay, multiplying and dividing. We're going to be talking about that in the next couple lessons, but give it a shot. See if you can use a little bit of extra brain power there and figure out what's going to be coming. So that's it. Those are your extra examples. Have a great rest of your day, and I plan to see you all tomorrow.